So in this video we just need to conclude problem number 4 from the quiz on section 2.8. In the first part of the video we found where this relation had horizontal tangent lines. So we found the derivative implicitly, we took the derivative, we set it equal to 0 by taking the numerator of it and setting it to 0, figured out that x equals 1, made that happen. We then had to figure out where on the curve x was going to be equal to 1, so we tossed 1 in place of the x's in the relation itself, and then we solved that equation for y, and we figured out we had two places where we were going to have horizontal tangents at 1, 4 and at 1, -4. We also wanted to figure out where on this curve we would have vertical tangent lines. So for vertical lines, you should remember that they have a slope that's undefined. And if it's a tangent line that's vertical, that means the derivative is undefined. So our derivative from the last video was this, and this fraction, this derivative, is going to be undefined when the denominator is 0. So when 2y is equal to 0. And that's simple to solve. You get y equals 0. But just like we did when we found where we had horizontal tangents, we don't know where on the curve y is equal to 0. So now we have to answer that question. So where on the curve does y equal 0? So I'm taking 0 for y, and I'm going to have to plug it back into the original relation in place of y and figure out what value or values of x makes that true. So I'm going to have x squared minus 2x plus 0 squared, 0 went in place of y, that's equal to 15. I need to be able to solve this. And truthfully, on the quiz, for people that made it this far, this was the thing that got missed most, solving this equation without a calculator. And anytime you solve something without a calculator, I've always been saying, try it by factoring. It'll normally be able to be solved by factoring if it's something I'm expecting that you're able to do without a calculator. And this is definitely one of those situations. But what a lot of people did, a lot of people just factored a GCF out here, and they had x times the quantity x minus 2. They set x equals to 15. They set x minus 2 equal to 15. There are an infinite number of values that multiply together to give you 15. 15 and 1/15, 30 and 1/2, 45 and 1/3, 60 and 1/4. We can keep going. The reason solving by factoring works is because if one side of your equation is 0, there is absolutely positively no way that you can multiply two things together and get an answer of 0 unless one of the two things happens to be 0. So you have to be equal to 0 before you try to solve by factoring. If you remember to move the 15 across and then you attempted to factor this, it would factor to x minus 5 times x plus 3. So this factor is equal to 0 when x is 5. This factor is equal to 0 when x is -3. So we'd have two places on the curve where we have vertical tangents. Both would have a y coordinate of 0, and then the x coordinates would be 5 and -3. So our vertical tangents occur at 5, 0 and -3, 0.